This video is on simple trigonometric equations. So you need to be able to solve trigonometric equations of the form sin theta, cos theta, or tan theta is equal to a number. So here's an example of this. So we need to find the solutions of the equation sin theta is equal to a half in the interval 0 to 360 degrees. So initially this looks really easy, and it is to find one solution. We just need to do the inverse sin of a half in order to find a value of theta. And if you put this into your calculator, this is equal to 30. However, notice that the question says solutions, plural, and this is because there are multiple values of theta in this interval here. So how do we find the other values? Now there's a technique used in the book to do with quadrants. I don't use this technique personally. I'm not even completely sure I understand it, to be honest. I use a different method involving symmetry. We talked about this briefly in the sine rule video. What I do is I draw a very quick graph for whatever it is. In this case, it's going to be the sin graph in the interval given. So it's here, it's 0 to 360 degrees. So I'm going to draw it really quick. I'm going to draw it quite big in this instance because in order to make it easier for the explanation, but it's usually quite small I draw it. So y is here, this is x, and the sin graph looks like this, where it comes up like this, it comes down. This is 0, this is 90, this is 180, this is 270, and this is 360, and it's in the interval 0 to 360. And I'm going to say half is about here. Remember, half is what sin theta equals. It doesn't really matter too much where you put half, as long as it's positive. So now we can see that there are two values of theta that equal a half. One here and one here. There's actually two. We know that this one here is 30 degrees because it's below 90, but we don't know what this one is. So what's this one? Well, it all comes from symmetry. This is how we find this value. And the fact that the distance between this point and this point, so the distance between these 2 points, is the same as the distance between this point and this point. Like this. Well, let's focus on this distance here. Well, we can figure out this distance because remember that we know that this is 30 because we know what this point is. So therefore this distance is just going to be 30 minus 0, which is just 30. So this distance here is 30, so therefore we know that this distance here is also going to be 30, and we know this point here as 180. So to find this point here, it's just going to be 180 minus 30, which is equal to 150. And that is the other point. This point here is 150. And those are the two values of theta. Theta is equal to 30 and 150. The step of finding the other point is very important, and a really good tip, a good way of checking your answer is by putting sin 150 into your calculator, and if you do this it gives out the value of half, and this is a good way to check that you have got the correct value of theta. It's really useful and I really recommend using it. Let's do another example. This time it is a cos graph and it's equal to 0.6, and it's a different interval this time, so watch out for that as the interval will usually change. So the first thing to do is to find the easy solution, which is the inverse cos of 0.6, which if you put into your calculator is equal to 53.13. Remember, it's the 2 decimal places. And then we're going to draw a cos graph this time, remember, between a different interval. So it's going to be like this. It's a cos graph, this is y, and this is x. It's going to come down like this. Draw that a bit smoother, come down like this, and then back up like this, and then down like this, and then like that, where this is 180 and this is minus 180. Again, the accuracy is just, the graph is just for you, so the accuracy isn't important. We'll say 0.6 is about here. And we see that there are 2 points, one here and one here. Whereas this one's positive, this is obviously going to be the 53.13. And remember, because of symmetry, distance between this point and this point is going to be the same as distance between this point and this point. Well, we know that this distance here is going to be 53.13, so it's 53.13 minus 0, so this is 53.13. So therefore, we can figure out this point from this point is just going to be 0 minus the distance, which is 53.13, which is obviously just equal to minus 53.13. So therefore, x is equal to 53.13 here, and the other point is minus 53.13. And again, a good way to check your answer is to do cos of minus 53.13, and it does give out the value that you're expecting, 0.6. Sometimes they can put a number in front of the sin, cos or tan. So here's an example of this where they want you to solve the equation 5 sin x is equal to minus 1, and they want it in the interval minus 360 to 360. So it's 5 sin x is equal to minus 1, and the way we approach this is just by moving the 5 onto the other side by dividing both sides by 5. So it's just going to become sin x is equal to minus 1 over 5. And then we just solve this equation instead. So the first thing we do is just do the inverse sin of minus 1 over 5, which if you put that into your calculator, is equal to minus 11.54. And then we're going to draw the graph. This is y, and this is x. Comes up like this, and then down like this, and then up. And we'll say that minus 1 over 5 is about here. And as you can see, there are 4 points. One here, one here, one here, and one here. So how do we get all of these points? Well, we know that this point here, because it's below minus 90, this point here is going to be the minus 11.54. Now, the distance between this point and this point here, this distance here, is going to be the same as the distance between this point and this point, because of symmetry. Now, of course, this distance here is just going to be 11.54, as this is 0 and this is minus 11.54. So therefore, now we know the distance, and we also know that this point here is minus 180, because we know the sin graph. This point is going to be minus 180, this point here, plus 11.54, which is the distance. And if you put this into a calculator, this is equal to minus 168.46. So this is one of the points. We've got 2 of the points now. We found another one. We can find this point because it's going to be the exact same distance here. It's going to be 11.54 again, and we know that this is 180. So this point here is going to be 180 plus 11.54. Remember, that's the distance. This is 180 and this is the distance. And if you put this into a calculator, this is equal to 191.54. And then with the same logic, this point here and this point here are going to have the exact same distance again, and we know that this is 360. So therefore, this point is going to be 360 minus 11.54, which if you put into your calculator is equal to 348.46. So x is equal to minus 168.46, remember it's two decimal places, minus 11.54, 191.54, and 348.46. I get that's quite lengthy, but it's going to be worth a lot of marks, remember, and it might be quite difficult just from looking at first time. Once you do enough examples, it will get a lot easier of understanding the symmetry. And again, a really useful trick is to check your answers by putting these solutions back into this equation at the top and seeing that it does give out minus 1.